All right, so I'm about to go over another method of determining the volume of a solid of revolution. Now, remember, in the last couple of lessons, we've been talking about how to calculate volume either by cross sections or in the case of volumes of solids of revolution, we talked about the disk and the washer method. Now, what I'm going to talk about right now is another method called the shell method, or it's also called the cylindrical shell method because we're going to talk about cylinders in just a second. So, for instance, the first example that I wanted to talk about was we're given this function f of x equals 1 minus 2x plus 3x squared minus 2x cubed over the x values from 0 to 1, and we're going to revolve it around the y-axis. And so here's what we're going to do. I'm going to go ahead and graph that first just so I know what it looks like. And I went ahead and already plugged in some numbers. Notice I've got this graph from 0 to 1 and also from 0 to 1. If I plug in 0, I actually get the value of 1. If I plug in 0.2, I get about 0.704, which is right about here. If I plug in 0.4, I get 0.552, which is right about here. If I plug in 0.6, I get 0.448, which is still kind of high up here in the 0.4 to 0.6 range. 0.8, I get 0.296, so it's right about 0.3, halfway between them. And at 1, I get 0. So I'm going to have this function that kind of looks a little bit like this. Now, I know I'm not the best artist, but you know that's sort of what my region is going to look like. And so right now, this is the region that's getting revolved. And in this case, we're revolving around the y-axis. So what's going to happen is, this is my y-axis. It's going to come down and look a little bit something like this. I'm going to call it almost like a Hershey kiss. It's going to be about what it looks like if I were to make the actual solid, if I were to make it a three-dimensional figure. It looks kind of like a Hershey kiss. In this case, I want you to think about trying to use the disk or the washer method on this. Since we're revolving around the y-axis, my disks, my washers, would have to actually go this way. Now, so this is going to be a disk because there's no hole in the middle. There's no gap. And so in this case, these would be my disks. But you notice I would have to be measuring it using the radius of the y values. So I'd have to turn this, since we're revolving around the y-axis, I would have to turn this entire function into a function of y. And the reason that I'm using a new method, the volume by shells, is because that's unreasonable. That's not an easy thing to do for your normal average everyday algebra student. Changing this into its inverse, changing this into y values, is not an easy thing to do. And so what I'm going to do instead is introduce you to the new method. Now, this new method, like I said, is going to involve the method of cylindrical shells. And so here's the thing. If I were to do disks, the formula that I would be using would essentially be pi times the radius squared, and I would integrate that. Here's the thing. That's circular. Notice my disks. Again, we're talking cylindrical shells, so the method that I'm going to use now is I'm actually going to integrate 2 pi times the radius times the height. And so this actually is the volume of a cylinder formula. And what I'm going to do in this case, again, is try to write this in terms of x's or y's and integrate over some bounds. Now that I've got that kind of idea going on, what I'm going to go ahead and show you real quickly is how this would kind of interpret my graph. And so here's the thing. What this method is going to do is it's going to take basically like a cookie cutter, and it's going to slice my shape, my solid, into a bunch of cylinders, okay? So it's going to make a bunch of cylinders of different heights that are kind of inside of each other until it makes the shape that I want, okay? So it's slicing it over and over, and you keep getting these cylinders all the way around that are going to make my full shape. And so the way I compared it in your written notes is it's kind of like those Russian nesting dolls, where you stick one inside the other until you get the big full nesting doll. And that's basically how it works. Is you're just going to keep sticking cylinders inside of cylinders inside of cylinders until you have the full shape all the way made out. And so let me repeat again. I'm going to try to write this formula for the volume of a cylinder, and I'm going to use it in terms of x. Now, if you look at this, if I look at my radius here, it's going to be just my x values in this case. So again, radius, this is my center, this is my axis of revolution. I'm going to use x as my radius, and the height is going to be the red line, this red curve given by this function. So essentially what I'm going to do is I'm going to integrate along my x's from 0 to 1. The radius that I have is just plain old x, because again, this is my radius, is how far out do I need to go along the x-axis. And my height is the 1 minus 2x plus 3x squared minus 2x cubed. Now again, let me repeat. This method is a lot easier than trying to turn this function into a function in terms of y and then doing the integration using disks or washers. So all I'm going to do here, this is a constant, 2 pi, so I'm going to take that out. And so what I'm going to do is multiply, distribute the x, and try to solve it from there. So here I go, taking out the 2 pi, then I'm going to distribute the x. So I'm going to have x minus 2x squared plus 3x cubed minus 2x to the 4th dx. All right, that's integrable. I can do that. So 2 pi on the outside, x becomes x squared, so I'm going to divide by 2. X squared becomes x cubed, so I'm going to divide by 3. 3x cubed, that x cubed is going to become x to the 4th. So I'm going to divide by 4. That's going to become x to the 5th. So I'm going to divide by 5. And we're going to evaluate that from 0 to 1. So if I were to plug in 0, nothing would be left over. So I'm just going to plug in the 1s, and that should end up pretty nicely. So 2 pi times 1 squared, which is 1, minus 2 times 1 cubed, which is just going to be 2. 1 to the 4th is just 1, so that's going to be 3/4. X to the 5th, that's 1 to the 5th, is just going to be 1, so that's going to be 2/5, and just add them all together. Let's see. So I've got 1/2 minus 2/3 plus 3/4 minus 2/5 is the final thing. So I've got 2 pi times 11 over 60, which should give me a final answer of 11 pi over 30. And so that is the volume of this Hershey Kiss looking shape, is 11 pi over 30. Now, a lot of people get this a little bit mixed up with the shells and disks method, where in that case you were using pi r squared. So notice in this case I'm not squaring anything. I'm using 2 pi out front instead of just 1 pi. But I do have to remember to take into account the radius and the height. Now I'm going to come back and do some more examples in just a minute. Hopefully this will help clear you up.